All right, so what we have here is a boring machine. This drill bit goes here, and when you hit the pedal, it comes forward and goes into your piece, right? So let's say you had a piece of plywood like this. The drill bit, you'd hold it here, hit the pedal, and the drill bit would drill into the end. What we want to do, we're gonna get a smaller drill bit for this. I think if we can get one for a 3/4 inch plywood, and then make it so that you can have it in here like this, and also hit it, and it'll make it so that when you put those two pieces together with dowels, they're flush where they join right here. Right? Well, at least that's the plan. If we can do that for this machine, then this machine's easily worth $1,000, because you'd be able to just walk right up to it and make a box in no time, right?
Well, we haven't quite finished it yet, but I'll tell you, it's been months now since since I filmed this video, and I don't know. There's been a lot that's happened, but it's coming together. I mean, we managed to fix some simple parts of it pretty quickly, but we keep getting distracted with other projects, so it hasn't been finished, and I really expected it to be finished like 3 days after we bought it. So here we're taking apart the wiring for the new motor to go in, and then we're installing the new motor, and it didn't actually go in the first time, and the reason for that is because once we taped up the lead ends, it wouldn't go back into the motor, so we had to go in a different direction there. But we did get it in, and you know.
So we're getting a new pulley at Northern Tool. That's $20, and Cross should be back with that at some point.
Here I'm going to remove all of the three-phase equipment from the outside. The motor, the contactor, the start-stop button, all of that stuff works and is good, so I'm going to package all of that up and offer that for sale on Craigslist. And the remaining machine, we've got to put a whole new set of electrics. We've got a nice 110 motor that's going to go right in there, fit real nice. Here's the new control box. I got this from Allied Electric. Going to install that on the side of the machine there, and put the wiring through there.
Alright, so I went to Lowe's and I got some power cord. What do we got here? This, I think, will work well as the cord for the motor, from here to the motor. I got some ends. This is going to go on the motor to shield the cord from rubbing up against the side of the machine. And I got some cable clamps, but honestly I think I'm stuck with this one. Alright, and went to Allied. And this was the button I originally wanted, but I kind of like how smart looking that one is. So I'm just going to leave that. This and this are needed to go behind this, so I think there we are. Alright. Yeah, I forgot to buy this part. When I bought the e-stop, I thought it was complete, but it wasn't. It was just the button, so I needed to buy that part. This I wasn't sure I was going to be able to get, but looks like I got it. So that is a nice little on-off label. I like to get the iDeck brand controls. They just seem to work well for me, and they're relatively inexpensive. Yeah, that's not going to work. There we go. More like that. Yeah. Oh, that's not even the on-off. Darn it. That's the emergency stuff. What was I thinking? Wait. I don't think this is supposed to turn. There's supposed to be a washer. That's not it. Alright. I'll be right back. Alright, so this is supposed to be like to prevent turning. I think it's supposed to go in there. And then you bring this up through here. Okay, come on. Yeah, see now that doesn't want to turn. So then that goes like that. There we go. And that locks on like that. Alright, so okay, this one already has the anti-turn. Come on. So something like that. Whoops. Guess on that gasket wants to go on there, and then that, then up through here. Come on. Alright. That is definitely, oh, there it is. Yeah, it popped right into place. Whoa, what happened there? Yeah, it's stuck though. It's stuck now. Alright.
Okay, and here I'm going to take the back of the motor, put the circuit board back in it, wire it all up, and then wire that to the new control panel and route the wire. Then I'm going to strip and prepare the power cord wire and connect that to the control panel and add an outlet to it. And then the last thing in this part of the video is I'm going to test the leads, not the leads, the controls. That's not right. Yeah, I'm thinking about it. I'm a little slow.
That's wrong.
Yeah, that's wrong.
When you push it in, there should be no beep. Oh,
Yeah.
damn it.
Yeah.
All right.
You bought the wrong module. I can't remember whether it was normally open or normally closed.
I think I've got it normally closed around here somewhere. I mean, yeah, normally closed.
Yeah, that must be a normally open.
Yeah, this is wrong.
Yep.
This is normally open.
Open means that the circuit has no connection. It's disconnected, right? Normally closed meaning the circuit is closed. That means that electricity can flow. I'm pretty sure I went looking for that and didn't find one and had to order it.
I gotta get one of these. I don't have an extra. I usually keep a normally open and a normally closed for each style that I use, but this is not the normal style that I use. It just happened to be the cheapest one, so it didn't turn out to be the cheapest one, because I think a normally closed is going to set me back like $8, plus like $15 or something for not hitting the $50 mark. So I got to go deal with that. This is normally closed. Previously we had a normally open, which is the blue one. So let's try this out and see what happens. Alright, so this, there you go. That means that power is able to transfer through, right? When the emergency is out. But then as soon as you hit it, it's gone. And then you twist it to release it, and it comes back. All right, so this time I got the right thing. All righty, so we got our ground wire there. We did that already. These are going to be our live, well, this is going to be our live wire. That's going to be our white wire. And I guess we'll do the same here. So what we're going to want to do is we're going to run the black wire through there. Yes, and first want the power to go through this guy. All right. Now, these two, I believe, are just going to get wire knotted together. So that white wire. That's our basically our ground. Not our ground. Our return is connect these guys together. All right, and this wire may be a little on the heavy side. It's fine. Excellent. Yeah, okay, those are going in. So that's nice. Toss this down towards the bottom there. Come on, stay down there. And then I guess we'll want to do something like this. All right, so that is a nice little control station. That's going to work out nicely. All right, so I'm going to just tell you what I'm going to do here. This foot pedal, when you push it down, it causes the machine to tip forward. It's lazy engineering is what it is. They just put a rim on the bottom here and put 4 holes, assuming that you're going to want to bolt that to the floor. These days, modern manufacturing, they don't have space, right? Every foot is a foot you have to pay for, every square foot. And so most of the time in manufacturing these days, you have to move equipment around. Maybe not every day, and obviously, ideally, you wouldn't, right? But it's just reality that that's going to happen. Also, we're converting this. See, this machine was already for sale for months and months and months. We're converting it to 110 because apparently nobody on the industrial level was interested. So we're looking to sell this to somebody who maybe just does a lot of stuff in his garage, and he wants a much faster way to put dowels into something, right? Joining things together and stuff. And this will do that. This is going to be crazy fast. However, also very accurate. However, it's unstable the way it is. He's not going to want to bolt it down to make it stable. So what I'm planning on doing is putting some 2x1 tubing right out to here, right under the pedal, so that when the pedal goes to push down, it'll counteract that force, and then the machine will be very, very stable. So we're gonna work on that right now, and if it works out, great. If it doesn't, then we'll put a second toe down here to stabilize it. But I think just having one here is going to completely change the machine and make it wonderful. And if that's the case, then we're done. So let's see what happens. All right, so the machine's back together. Just to go over, we've reversed this. This bar used to be, well, this assembly here used to be this way, and so this angle here was sticking out over the table. That was useless. So we flipped that around. We've got the box on. Everything's working nicely. We got the new belt. The counterweight is back on. Still waiting on a new drill. We rearranged the assembly for the motor so that we've got a good 3 inches of, I don't know what you call that, thrust, forward motion, whatever, right? So we've got probably more forward motion than the drill bit is going to have, cutting depth, right? We've got a new pulley down here. If you listen, we've got a horrible vibration. And it's this right here. If I just hold that to the left here, then we don't get that vibration. I got, like a 1/16 of an inch there, and that's just enough to keep it off the frame so it doesn't vibrate. So it's all good. All right, moving right along.